Hey gang, this is the first in a series of videos where we're going to look at the limit of a function of a real variable. And again, I'm going to work through a worksheet that we would have had live in class, which you can download from Schoology. And like most classes, I'm going to start a little warm up where it says graph that function. Of course, that's a rational function, x squared minus 16 over x minus 4. And don't forget to, on your calculator, you have to, a rational function, you have to group the top and the bottom with parentheses before you hit the division key. And then it says, hey, of course, when you do, if you look at the graph, actually graphs as a straight line because you have second degree divided by first degree, which really gives you a first degree equation. But what I wanted to do is specifically look at x equals 4 because we know that when you plug 4 in, you'll have division by 0. Specifically, f of 4, and I can't believe I used the highlighter there. F of 4 actually equals 0 over 0, which is called an indeterminate form. Let's spell that out. Terminate form. And early in the year, we kind of saw that when this happens, you actually get a hole in your graph. So, f of 4 doesn't actually exist because you have division by 0, but something interesting happens as you pick x values very close to 4. So if you actually set the table, that's table set is on your graphing calculator just above the window key up top. It's in blue on mine, so you'd have to hit the second key and window. And you could set the table to start at 3.9 and then delta table, which means how much do you want to increment the table, do it by 1/100, 0.01. And you will get, your x's will be listed as 3.9, 3.91, 3.92. It'll just keep going. And your next column should show you the y values with this y1 function plugged in. And it turns out, look at what happens as your x's go from 3.9 to 3.99. So in other words, as they approach 4, so the x's are going towards 4, the question is, what are the f of x's? So where are the y's getting close to? 7.9, 7.91, 7.92, 7, all the way to 7.99. Even a middle school kid could tell you, well, they're getting really, really close to 8. So as you take numbers just below 4, the y values approach 8. That's what we mean by a limit in the simplest term. And since these values, the x values are all left of 4, we call that a left-hand limit or a lower limit. Same thing here with the numbers above 4. So if we start with 4.1, the x's, and we decrease them by 1/100th all the way to 4.01, right? Remember, the x's are still getting close to 4. We can say, hey, what's happened to the y's? Well, they go from 8.1 to 8.09 all the way to 8.01. They get really, really close to 8. Are they going to get there? No, because at 4, remember, we don't have a function. It's a hole. But, what would happen on the graph? We'd have a hole at x equals 4, y equals 8. So that's kind of the warm-up, gives you an idea what a limit is. So if I look at this introduction below, what happens as x approaches from the left? Well, we just said the y values get close to 8. So the limit is 8. Doesn't mean we never get there. We could get there, we just don't get there. And the way we write this in math is we use this symbol, lim, right? And we say, as the x's approach 4, and again, we're saying from the left, from lower values. And the way we denote left is with this little negative superscript. And we say the limit of that function is 8. So that's called the left-hand limit. And again, conversely, if you take x's that are just above 4, like 4.05, 4.04, 4.03, really close to 4, but above, it's the same symbol, we say the limit as x approaches 4, but we say, hey, we put this little plus meaning the right side. In fact, this is really one of the only times in math where we use a superscript of a plus and a minus. You know where you see it? You see it in chemistry class for isotopes. Usually the pluses and minuses come before the number. If they come after, we're talking about limits. And of course, even on the right side, it gets close to 8. So overall, what's the limit of this function? If the left-hand limit equals the right-hand limit, it happens to be 8. So I'm going to stop it right there. We're going to look at some more examples of limits in upcoming videos.